Welcome to Chapter 9 Introduction to the Normal Distribution for Statistics 1. This is an introduction video, and for now you do not need to be taking any notes, you just need to watch and absorb. In Chapter 8 we worked out probability questions to do with discrete random variables. In Chapter 9 we will work out probabilities of a specific type of continuous random variables called the normal distribution. Now, the normal distribution is a really important concept in statistics, and it is widely used. For example, suppose you wanted to make a histogram of the FIC student's height. The y-axis will be frequency density. Now, what will the histogram look like? You should pause the video and think what the graph will look like, or if you can't remember, maybe have a quick flick through the histogram section in the statistics textbook or your notes before you continue the video. You should pause the video. Okay, I hope you had a think about that. The graph should look something like this. Now, the histogram will have a really high mean, high frequency at the mean, and the frequencies, well, the height of the bars will decrease as it gets far from the mean, and the height of the bars will be really low, really far from the mean. And there should be some kind of symmetry about the mean, which means that both sides of the mean is a mirror reflection of each other. This shape is called a bell-shaped curve, and this is what the normal distribution is. It's basically a continuous histogram which has a bell-shaped curve. And from this, not only can we work out how many people have certain heights, but also the probability. For example, if someone asked what is the probability of a random FIC student having a height less than 165? Well, from the graph we can see pretty much half the people have less than 165, so the probability will be half. But what if we were asked some more specific question like this? What is the probability of a random FIC student having a height between 150 and 160? So we're looking at this section here. These are the type of questions that we will be able to answer in this chapter. The key is the histogram tells us the proportion, the area of the histogram tells us the proportion of the total, so we can work out the probability. Fortunately, the mathematicians worked out a magical formula which tells us such probability. Unfortunately though, the formula looks something like this. Now, before you consider quitting maths altogether, fortunately, we don't have to use this formula. All you need to do is to read the values from a given table, which looks like this. This is at the back of your S1 textbook and will also be given to you in your exam in a formula booklet. Unfortunately though, the table doesn't cover all possible cases. What I mean by that is, there could be a normal distribution that looks like this, there could be a normal distribution that looks like this, there could be a normal distribution which looks like this, or there could be a normal distribution which looks like this, really shallow. But we only have a table for what's called a standard normal distribution, which the mean is at 0. Fortunately, we can use the transformations we learned in C1 to shift the mean and to stretch or shrink if necessary to make all these different normal distributions look like the standard normal distribution. There is one more problem or difficulty in that the table only covers or tells us probability of a value less than such a number. So what it doesn't tell us is a value bigger than a certain number. Another thing is, the table only covers the right half of the side. In other words, it doesn't tell us probability of something like this. Fortunately, we can use the symmetrical property and using the total area to work out all these different cases, and we will learn this in later sections. For now, let's just make some notes about the normal distribution. So in your orange book, write down the title, Chapter 9, Normal Distribution, and the subheading Normal Distribution, and please write this at the center of your book, capital X, curly line, capital N, bracket, mu, comma, sigma squared. This just means that the continuous random variable x is distributed with a normal distribution with a mean mu and the standard deviation sigma. This is a shorthand for writing that the continuous random variable x is distributed with a normal distribution with mean mu and standard deviation sigma. Now remember that normal distribution is a bell-shaped curve, a continuous histogram, which is a bell-shaped curve. So make a note of this. It is symmetrical about the mean, so it's reflected on each side, half. And we make the proportions so that the total area equals 1. We do this so that the area represents the probability. So if, for example, if this was 2 and 4, the probability of a random variable being between 2 and 4 need to work out the area of the graph. This will be covered in more detail with examples in later videos. This is the end of the introduction to the normal distribution. Thank you.